John finances his daughter's college education by making deposits into a fund earning 8% effective annual. For 18 years, he deposits X at the beginning of each month. In the 16th through 19th years, he makes a withdrawal of 25,000 at the beginning of each year. The final withdrawal reduces the fund balance to zero. Calculate X. Now, if the final withdrawal reduces the fund balance to zero, what that means is that the value of the deposits at any time equals the value of the withdrawals at any time. And we can choose any common time that we like. So let's first write this information down. And the other thing to note is that the annual effective interest rate is 8%, but the deposits are happening at the beginning of each month. So since they are monthly deposits, so we will need to convert this yearly rate into the monthly rate. And let's call the monthly effective rate as J. And so that would be I superscript 12 by 12. And by 9.1, we have 1 plus I equals 1 plus IM by M power M for any M. In this case, M is 12 since it's monthly. And so the annual effective rate is I, which is 8%. And I 12 by 12 is the monthly effective rate, which would be J. And so you take power 1/12 on both sides, and then you subtract 1. So J comes out to be 0.006434. And now, as we said, since the withdrawals completely drain the account, the value of deposits at any time should equal the value of withdrawals at that time. And the common point that we are going to choose is time 0. And deposits happen for 18 years and they're monthly deposits. So we need to know how many months are there in 18 years. So 18 times 12, there are 216 months. And since the deposits are happening at the beginning of each month, and we want the value at time 0, and time 0 was where the first deposit was made. So this is annuity due. And so the present value, according to 33.3 equation, will be X times 1 minus 1 plus J to the negative N over J. So remember, this part was just the immediate formula, and then for the due, we multiply by 1 plus J. And so J, we found out above, and substitute J and substitute N equals 216 months. And we end up getting the present value of deposits at time 0 is 117.28x. Now, withdrawals of 25,000 happen at the beginning of years 16, 17, 18, and 19. Remember, that's what the problem was saying. Between 16 through 19th year, withdrawals of these happen at the beginning of each year, which means that they happen at the beginning of year 16, 17, 18, and 19. Now, the beginning of year 16 is actually time 15, because like the beginning of year 1 is time 0. So beginning of any year is, if you want to find the time corresponding to the beginning of any year, you go one less. So the beginning of year 16 is actually time 15. The beginning of year 17 is time 16. Beginning of year 18 is time 17. And beginning of year 19 is time 18. And so it means that the withdrawals are happening at times 15, 16, 17, and 18. And as we are collecting everything at time 0, as we mentioned above, so the value of this first withdrawal, which happens at time 15, its value at time 0 is obtained by pulling it 15 years back. So it would be 25,000 times new to the 15. Similarly, for the second one, we'll pull it 16 years back. It would be 25,000 new to the 16, and then 25,000 new to the 17, and then 25,000 new to the 18. And new, we know, is 1 plus I power negative 1. So in this case, it would be 1.08 negative 1, since the interest rate is 8% annual rate. And so we can factor out the 25,000 and get 1.08 to the negative 15 plus 1.08 to the negative 16 plus 1.08 to the negative 17 plus 1.08 to the negative 18. Now you can also find this by annuity due formula and then pull it back 15 years. But when there are such few terms, then sometimes it's more convenient to just do it by brute force, as I'm doing here, and only 4 terms, so I can just do it by brute force. And so the value of these withdrawals at time 0 is 28,191.25, and then, as we said, present value of deposits equal present value of withdrawals. So 117.28x was the present value the deposits, that equals 28191.25, and this gives us x equals 240. That is choice C.